Welcome. Today we'll talk about a fascinating topic, vacuum physics and how they will in the X-ray laser and intense magnetic fields. In a vacuum, according to quantum electrodynamics, QAD, photon can interact with each other via virtual electroloops, a fully non-linear phenomenon. This, this interaction is described by the Euler-Heisenberg Lagrangian, which add for fields electromagnetic terms for energies and fields much below QED's critical values. Um, Number one, X-ray photon scattering. Um, we split pulse from an XF L the spring H Armstrong compact field in, into two coherent beams using a silicon beams splitter. Team force team to collide obliquely. Forward scattered photons have high, higher energy 18.1 to 19.9 QAB, separating them from background. In the first experiment, Julio 2013, we injected 6.5 times 10 to the 5 pulse without detecting any signal events, setting limits on the QAD cross section in the X-ray region. By improving the splitter, laser monochromaticity, and runtime, we achieved an 1000-fold sensitivity gain in 2015, though we still 9 about 20 orders of magnitude more to reach the breathed QAD value. Number one, laser inducing birefringence and diffraction. We use palm probe scheme a high power laser about 1 electron volt pumps the vacuum and an X field around 10 electron volts provide it. The change in polarization is called quantum vacuum birefringence and the beam angular deviation in vacuum diffraction. To synchronize both beams in space and time about 1 picosecond and the micrometer, we erected a zinc fin and examined the bobined imprint under a microscope, arching an overlap of the 10 micrometer. With upcoming metawatt laser at SACLA, we plan the first full measurement in 2018. Number three, vacuum magnetic birefringence. We adapt the cotton mountain effect for vacuum racetrack pulse magnet generate fields up to 12 Teslas with a repetition rate of 0.2 Hz over a total field length of 0.18 meters, combined with a Fabry Perot cavity with finesses of 650,000, an automatic resonance recovery system after H pulse maximus that talking efficiency. And the last number one, number number four, searching for new physics. And yes, in action like particles, ILPs that couple to two photons could modify test signals using the light shining through a wall. Technique in X-ray, all ILPs are generated in one magnet pair traverser and being dumped and reconverted into photon in another magnet pair. In in 2015, at Sprint H B Eul 19 XU with around 27,600 to 76 pulse knock signal appeared tightening the clopping limits by a factor of 5.2 compared to previous X-ray ILSW searches.